very quiet ride. There's that demonstrator. Look for, see if you can see the...
This is going to be a fun show because we're going to make a very important announcement, and this is going to be a unusual thing at the Society. We're making an announcement about our company's future, and we deliberately didn't put out a press release on it. We're putting the press release out after this meeting. And I've only told a couple of people. I told Buzz Aldrin what we were doing. I told a few other people. But you're going to be in for a little bit of history here if we're fortunate. So first of all, I'll introduce myself. My name is Art Dula. I'm chairman of Excalibur Almaz Limited. That's a British company. It's an Isle of Man company. And to my left here is Buckner Hightower, who is the Chief Executive Officer of Excalibur Almaz Incorporated, our American technical and management support company. Next to me is Russell Dula, who's a project manager with that company for two of the activities that we're doing in the next 6 weeks. I'm going to tell you what we're going to do here, then I'll give you a little bit of background, and then we'll get right into the presentation, which, as I said, I think you'll find interesting. This meeting at the International Space Development Conference is the first of 6 weeks of presentations that we're making. This presentation is going to be a technical proof of our concept of private human spaceflight. It's going to tell you where we are and where our company's come from in the last 7 years, during which time we have not announced what we're doing. We just have been doing it. And what we plan to do then, a few weeks from now, on the 19th of June, we'll have a presentation in London at the Royal Aeronautical Society 3rd Space Tourism Conference. And at that conference, we will display a spaceship that has flown to space 2 times, has flown to orbit 2 times, and that will fly there again. We'll display it to the public and to the members of the Society and to European industry. And at that conference, we will make our financial presentation. We'll talk about our source of funds, use of funds, exactly what we're doing financially, and how our financial business case and models close. We'll talk a little about that today, but not much. And then on the 9th of July, at our home on the Isle of Man, at the Cherbourg Royal Air Station, on the north of the Isle of Man, there is a conference on space, and we will display our cislunar spaceships that will travel between Earth orbit and the Moon and L2. These spacecraft already exist. They're already in Britain, and the technical details will come in a minute. Now, I realize that many of the things I'm going to tell you today are going to sound a little unbelievable. They're not unbelievable. They're based on very solid facts. And our company has a track record of technical accomplishment. It's just that we haven't made it public in the past. And this is our public debut. For myself, I incorporated the Space Services Incorporated of America, which launched the first private space vehicle from Matagorda Island in 1982. It was quite successful. It went to 182 miles. It was a suborbital flight, but it went into space, and it was the first American privately owned vehicle to do so. Buckner Hightower and I, back in 1987, incorporated the first company that traded with the Russians, and we bought and sold Proton rockets. Proton's now an extremely successful commercial launch vehicle, and we sold the first 3 to Hughes Communication. I also was a founder of SpaceHab, which was a private company taking modules into space on the Space Shuttle. As a matter of fact, it flew some 17 times and was quite profitable. It was a public company. During the time that I was working with the Russians, I found a series of spaceships that they had kept secret, and we have now purchased them, and we're going to use them for private expeditions. Would you please put up the first slide? Okay, now, just as a summary, let me tell you what our company's done. First of all, we have purchased 4 reusable reentry vehicles. They're 3-person manned spacecraft, and they've flown. They're at a very high technical readiness level, and 2 space station frames. These stations, identical stations, have flown 3 times in the past, and very similar stations are operating in space now as the Zvezda module of the ISS and operated for 15 years as the core module of the Mir space station. We performed a lot of technical work with our primary U.S. contractor, United Space Alliance, that operated the Space Shuttle program, to learn all of the heritage of the Space Shuttle program that would be applicable to private spaceflight. We have that, although United Space Alliance now does not operate the shuttle because the shuttle program is over. We hope to continue the heritage of safety and reliability that costs so many billions of dollars for Americans to learn it. We also have our principal contractor, Astrium, EADS Astrium in Europe. We are a European company, and they're designing parts of our spacecraft and bringing them back up to date. We're working with companies like Paragon for life support and many others. We have received our technology agreements through the U.S. Department of State with Russia, with Europe, and the United States. And we have very broad licenses to do technology exchange and technical development of these spacecraft. Now, for those of you who are not lawyers, I happen to be a lawyer, but for those of you who are not, this is even more difficult sometimes than the technical part of a space program, is getting permission from the various governmental authorities to take and do the work because of the ITAR and the other restrictions on the international discussion of technical data that has to do with aerospace. But we have those licenses, they're in place now, and they're modeled on the licenses that were used to build and operate the International Space Station and to operate the Space Shuttle with the 14 foreign partners under the Intergovernmental Agreement on the Space Station. We also have the export licenses from Roscosmos, the Russian space agency, and the Russian government that allow us to bring these spacecraft out of Russia. And in fact, they have been legally exported. They are now in Britain on the Isle of Man in our Derby logistics facility. And those licenses allow us to use this equipment in space. The important thing is to realize that we're building a private space program. We've also executed a Space Act agreement, an unfunded Space Act agreement with the National Aeronautics and Space Administration of the United States. Now, there are 3 companies that have this type of an agreement for the commercial crew program. One of them is United Launch Alliance. The other one is ATK. They're working on boosters. We're working on a space transportation system. We don't immediately expect to take and work with NASA delivering crew, but we need to understand what the NASA requirements are to carry human beings in space. And again, we want to learn from this incredible technical heritage. So, from a business point of view, we have performed 4 market studies. They were done by contract with the Futron Corporation of Washington, D.C., which is an acknowledged world leader in understanding the econometrics of space. We did these on orbital and cislunar market demand for private expeditions, for government expeditions and government cargo and crew to the International Space Station, for combined missions that might take and do some of both of those tasks. And finally, we updated the entire group of studies that was begun in 2009, middle of 2011. And we found a very surprising thing. The market for low Earth orbit activities requires government subsidy at this time. You can't do it and make a business case close purely on commercial activities. Now, in the future, of course, it will close, but right now, it requires a government subsidy. We were pleased, however, to find that there was a market that did close very well, and it closed without government funding from NASA, and we are pursuing that market. We found that between 2013 and 2022, a 10-year period, the total demand for private lunar expeditions would reach perhaps 29 lunar passengers, and it's at a price point of about $100 million per passenger. Now, this was surprising, and it's a very good sign because this presumes current events, and there is no doubt that in the next few years, cislunar space is going to become an extremely important commercial topic. So let me go on and walk you through our technical presentation. Our approach to business is different than SpaceX or the other companies that are being built by the several billionaires that are trying to get into space. We're not really trying to build anything new. We're trying to leverage the billions of dollars of investment by many spacefaring nations, by the Russian Federation, by the United States, by the European Union, and to apply advanced technology to proven systems so that we have an effective means of access to space for commercialization, for research, and for applications. We began with a series of studies about 2005, 2007 in Russia on whether or not it was feasible with the current level of Russian industrialization to do this, and we found out that it was. We then began purchasing spacecraft and going into design and reissuing drawings to current specifications for all of the important systems that were criticality one to keeping people alive. An example is the parachute system. We've now reissued all technical documentation for this system, and we are ready to build it to print. We don't have to do research, except for batch testing. We don't have to do testing, and we have agreements in place to buy 10 of these units. We just have to pay the factory to build them. They're the same that were used in the past, and I'll get into our test history in a minute. The same with our liquid rocket engines for attitude control and for the various spacecraft that we are using in this program. We are going to have to take and update the launch system. We'll probably be using the Soyuz FG, though we can fly on many other vehicles. We also looked into using space stations that were left over from the Soyuz and Salyut programs. And we purchased some of these stations. I'll show them to you in a minute. So we have the benefit of the test heritage that are in these systems for many of the mission-critical and crew life-saving critical systems. Our approach begins with this proven hardware, and then we develop a modular transportation system that uses equipment we already have today and launch vehicles that we can contract for. We don't have to build a launch vehicle. There are several that can carry this equipment today. The critical elements of our low Earth orbit space transportation system are at technical readiness level 9. This is the most important thing that I have as a message to let out today as part of this talk. Our aeroshell, our system aerodynamics, our emergency escape system is fully proven and has been tested in 9 flights to orbit. The parachutes, the pyrotechnic devices, all of the seals and hatches and mechanical equipment are technical readiness level 9. And this is part of what we've been discussing with NASA in our Space Act agreement, we've been working with a technical team from the Space Center in Florida and in Houston to take and validate our system models and to see if we can meet NASA's requirements. Again, we don't expect initially to carry people to the International Space Station. We're going to do private expeditions because we believe that the economics and the business case for private expeditions is better than the NASA case for going to the International Space Station. And we're also not an American company. We're a British company. Now, our goal is to provide an affordable space system, an affordable commercial space system. And here we are with our reusable reentry vehicle. It's an artist's conception over England, over the Isle of Man, which is our home. We own 6 spacecraft today. 4 of them are reusable reentry vehicles. They mass about 3 tons each. That's the return part of the capsule. They're conical, about 3 meters in diameter, and they have about 4.5 meters of habitable volume. So they're quite small, but they have the ability to carry 3 people up to orbit as a taxi. They've flown 9 times to orbit and returned safely. And these spacecraft are now on the Isle of Man in Britain, and that we have the licenses to continue to develop them. Of course, we will have to apply for licenses to fly them under the British Outer Space Act of 1986 with the British Space Agency. We've already put in a preliminary license application to the British Space Agency, and it is being reviewed. These spacecraft are space shuttles. A space shuttle is not a winged vehicle. A space shuttle is a vehicle that can fly to orbit repeatedly. The Russian factory that built these has conducted extensive tests on the spacecraft in their current condition. They are 30 years old. And their conclusion was that we can fly these reusable return vehicles to orbit at least up to 15 times on 15 missions. And that is without refurbishment of the thermal protective system. It's an extremely robust system. And we, of course, have all of the details of the testing that they did on these systems, both during their design, development, flight, and the retesting they did after we bought the systems in order to qualify them to be used again. We're going to have a system that uses a common crew return vehicle that we already own and that already has all of this testing and heritage, which by the time you do 9 test flights surely must be a couple of $2 billion worth of value. We're going to combine that with building to print all of the systems that were proven in the past, like the emergency escape system, the deorbit engine system, the liquid rocket engine system, and we're going to combine that with an intermediate propulsion stage that will be designed by Astrium in Europe and will use the technical heritage of the ATV vehicle, which is already space-proven on several flights and is qualified to dock and rendezvous with the International Space Station. In addition, Astrium has provided us with the preliminary design of our cargo and passenger modules, again based on ATV technology. So here there are 4 different vehicles. The one on the left-hand side of the screen is a manned vehicle to shuttle up to our cislunar spacecraft, which will be the spacecraft that goes between the Earth and the Moon. It does not have a habitation module. It's just a taxi. It has a propulsion stage, and the rest of the system is the heritage system I've been describing. We can also, if anybody would like to take in contract for it, after all, we're in the business of chartering this equipment, We can fly this vehicle with a habitation module and stay in space for up to a week on a private expedition. We don't have to go to a space station for this. The system can be self-contained for a week, and there's a pretty good-sized habitation module that you can move around in, have a couple of windows and things like that. Again, it's got the proven and tested emergency escape system. And the emergency escape system, by the way, is a major cost driver in any manned commercial space vehicle. Elon Musk has estimated that it could cost up to $500 million to qualify and build and design the emergency escape system for the Dragon capsule. It's a big piece of work, and we have that now. The other two vehicles, the ones without the emergency escape motor on the top, are cargo vehicles. They would fly under the shroud of the launch vehicle, so they do not take aerodynamic loads. And one of them is a pressurized cargo module, and the other is a partially pressurized and partially unpressurized module that can carry up critical cargo to a space station. We designed it for the International Space Station to carry up two large pieces of equipment that are carried unpressurized. I think they're called gyrodynes or something like that. I'm the lawyer for the company, but it also has the ability to carry up space station racks, and it can carry down back to the Earth up to a metric ton of return cargo inside the capsule. Now, the other two spacecraft that we own are the frames of Salyut space stations. They're about 20 metric tons on takeoff. They're designed to be launched on the Russian Proton launch vehicle from the Baikonur Cosmodrome, and they would go into an orbit of 51.6 degrees. One of them has the rocket engine propulsion system on it and all the attitude controls. The other one is a pristine space station frame with airlock and the remote cargo canister drop system that these stations had. 14 meters long, about 4 meters in diameter, and about 90 cubic meters of habitable volume. So they're very large stations. They are roughly the same as the core module of the Mir space station or a Salyut station or the Zvezda module on the International Space Station. Now, these systems have operated in low Earth orbit with routine maintenance for up to 15 years. So we feel that we can say that we can hope for a 10 to 15-year useful life for this piece of architecture that we're planning to put into initially low Earth orbit. All of these are currently at our facility in Great Britain. And I must tell you that the cost of the legal work to take and properly export and document this equipment is pretty roughly the same as the cost of the engineering on it. Now, here's an example of one of these modules up in orbit on the International Space Station. We believe that our spacecraft, our station spacecraft, are comparable to those used in the past. And we're going to take and do non-destructive testing on them, upgrade the onboard equipment, the flight control, communications, all of the computers. And we're going to equip these stations with high-powered electric engines. Initially, we're thinking about using Hall thrusters. We're still in the selection process for our engines, but we have found engines that are capable of moving these spacecraft to the moon and back that are electric. Now, it will take longer than a mission that uses chemical fuel, but these types of flights have been done before with smaller spacecraft, and these electric engines are in the process of very rapid development today. We have found off-the-shelf engines that exist and off-the-shelf solar arrays to provide the electric power. And we've also found some very interesting new developments, such as the Vasimir engine being developed by Franklin Chang Diaz. All of this, if you're interested in it, we can sign an NDA, and with clearance from the appropriate officials at the State Department, we can discuss it with you. Now, so this is our spacecraft. This is the entire spacecraft. The spacecraft is the taxi, the reusable reentry vehicle that goes up to orbit from the surface of the Earth, and the station spacecraft that goes from Earth orbit to the Moon or to the Euler-Lagrange point behind the Moon, and it can go to many different destinations that are of scientific and commercial interest. But we are going to create a transportation system that can carry products, payloads, that can perform logistical support for other people, for example, people who want to mine asteroids, and can carry crew between the Earth and LEO and Earth orbit and the Moon. So we have a cislunar space system. Our business objective follows directly from that. We can't tell what's going to be done in these orbits. We can't predict accurately what research needs to be done, what commercial things will come about, but we can provide an infrastructure based on proven technology that's been tested and flown in space many times, updated with the latest equipment, and we can do it at a very reasonable price. So we expect to be able to offer crew and autonomous access to low Earth orbit, lunar transfer orbit, low lunar orbit, and L2 and beyond for all forms of commercial space activities. Now, the station can be manned by up to a crew of 3 for these flights, or it can operate independently under remote control from the ground. So it can fly autonomously to do science when it's not carrying people. So we're going to develop this commercial space system, and our customers will be individuals, corporations, and governments. And this is where we're going to be operating. Now, I stress that we were quite surprised to find that we can't operate in low Earth orbit at a profit right now. That takes government subsidy. The flights simply are, there aren't enough customers in low Earth orbit. There are more customers that are interested in going beyond low Earth orbit for a purely commercial system. So let's look at 3 potential missions. And these are missions that we've identified that we can fly with this set of tools. The first one is going from the Earth to the Moon or to the L2 point beyond the Moon with a crew in the station all the way. The station is launched to low Earth orbit. It's checked out, and a single test flight with a test pilot, and by the way, our test pilot will be at the conference in London, is launched to low Earth orbit, rendezvous and dock, and check out the station. Then the test pilot returns to the Earth, and we've now proven the transportation system. Our next flight is a commercial flight of 3 passengers who rendezvous and dock with the station, and the ion engines then spiral the station out from the Earth and do a low energy exterior transfer to the Moon. This mission is a flyby of the Moon with a return to Earth orbit. A nominal second mission is to take and fly the station independently under remote control into elliptical lunar orbit that precesses through L2. Again, using an exterior transfer, low energy trajectory, and a zero energy capture into elliptical lunar orbit. Our trajectory analysis is being done by Dr. Ed Belbruno at Princeton, who was a pioneer in this type of work. But there is also ongoing work at the Jet Propulsion Laboratory and in other places that are studying these low energy trajectories. Then a high energy mission, possibly an Orion mission on a Atlas or other launch vehicle, would be launched and would take 3 to 4 to maybe 5 days to get to the moon, and would rendezvous and dock with the station spacecraft. The crew could then take and use the scientific and support and logistics facilities of our spacecraft for a period of a month or 2 months or whatever the government contracted for. And then the Orion or any other lunar-capable spacecraft would undock and would fly back to the Earth doing a trans-Earth injection burn and would come in at somewhat a higher speed than an orbital speed. It's, Buzz knows all about this. It's coming back at about 25,000 miles an hour. I don't know of anything that can do it other than the Orion, but the Orion was designed to do that kind of a mission. And then a third nominal potential mission for our spacecraft would be to fly back to the moon on a low energy trajectory, and this time to pass by the moon in such a way that it was thrown out of the plane of the ecliptic into a cyclar orbit, a moon-to-moon transfer orbit. Now, I feel a little nervous about talking about this because Buzz developed these orbits and he's sitting in the audience. But I've been told by our technical people that by the time the spacecraft completes this 2-week flight, the moon will have moved around to where the spacecraft will again encounter the moon when it comes back into the plane of the ecliptic, and then we'll use lunar gravity to take and alter the trajectory of the spacecraft back toward the Earth. The advantage of this is that as long as you have a certain amount of delta V capability to trim the spacecraft to take into account the other gravitational forces, such as the errors you make plus Jupiter and the Sun, you can maintain this orbit with very little propulsion. It has the disadvantage that when you go by the Earth, you're going at a high rate of speed. And so you have to have a high energy upper stage if you're going to do a rendezvous and docking with it. Again, this presumes that everybody else is developing the capability to do that kind of thing. We could take one of our space stations and actually deploy it into a halo orbit at L2. And this is something that NASA has been looking at as a goal to take and provide a facility at L2. There's even been some talk about taking the current space station apart and moving some of it to L2. Now, I don't know how technically feasible that is, but we certainly could take one of our space stations and we could move it to L2. This would probably be on a government contract, and as I said, our initial business planning doesn't assume we'll have any government contracts. Now, we're going to purchase the most effective launch vehicle. We're going to compete launch vehicles. We've looked at the Atlas V, the Falcon 9, and the Zenit. In fact, our company looked at buying Sea Launch when it was in bankruptcy last year. We actually financed it for about 6 months while we looked at it, but it was finally purchased by the Russian company Energia. It's now a Swiss corporation. But the Zenit was built to be man-rated, and it can be man-rated at a relatively low cost. We have a quotation from the factory on man-rating the Zenit. The Falcon 9, Elon has told us, is certainly going to be a manned vehicle, and ULA is working on a project to man-rate the Atlas V. At the current time, our capsule can only launch on the Soyuz FG because it is the only manned launch vehicle we have access to that's man-rated. The Long March 2F is also technically capable of launching our spacecraft, but we are forbidden by ITAR and by U.S. government policies from contracting for it. We're hoping eventually that we might look at some of the new launch vehicles that are being built, such as the Liberty, for the possibility of launching this spacecraft. And our heavy spacecraft, the one that weighs 20 tons, can be put up on the Proton. That's what it was designed for. And the Proton has lifted about 20 of these modules into orbit, or similar modules into orbit. It also is within the lift capability of the Delta IV, the Atlas V Heavy, and the Ariane 5. I might also mention that it could be launched technically on the Mitsubishi H-2B, but that is not a commercial launch vehicle at this point. So let me tell you in a little bit of detail what it is that we had to do to get to where we are today. Well, first of all, anybody that works on a commercial space program has to have a license from the federal government. And so we have a technology assistance agreement through the State Department to allow us to work with our European and Russian contractors. We also have a unfunded Space Act agreement with NASA so that we can gain the benefit of their knowledge of human spaceflight and understand the requirements that NASA has set for human spaceflight. And we've gone into considerable technical detail. This is one of the slides from a presentation that was a discussion presentation with NASA on how exactly we are going to refurbish these spacecraft. We're looking at the possibility of moving from our 3-person manned reusable reentry vehicle into a 6-person manned reusable reentry vehicle. And the technical work that has been done on this by our Russian contractor, NPO Machinistроения, is between preliminary design review and critical design review at this time. And here we're back to the spacecraft drawing I showed you before. Our whole business theory is driven by market demand. And the only way we can estimate market demand is to get the very best advice that we can from the very best people we can. We've done that